Okay, it should be recording. Did it ask?
Yeah, it did.
Oh, okay. So I'm assuming it's recording. Okay. Right, we can get started now. Should I just go over the technical report now? Okay.
I want to screen record this just in case too.
Okay. Might be a lot of storage. Let me share screen with you real quick. Okay. All right, Al, can you see the screen?
Yeah, I can see it.
Okay, so we're just gonna go through this just like really quickly because there's a ton of pages in here. But we can start with the introduction. So we're the UC Arca Project Solids team. I'm Preston Ria Donata. I am the project manager and operations lead for the project.
And I'm
Okay.
Brian. And I'm Brian Boo, and I'm currently the chief engineer for the project.
Yes. And then other people over there, yeah, I guess they can introduce. But Eric is also our chief. He might show up later if you have any avionics questions and Hala also for hardware avionics. Here's our technical report, our abstract and stuff. But we can start with I don't think we need to.
Yeah.
But here's our current model of our rocket from SolidWorks.
Okay.
Over in details. That the top is pretty much what it looks like. You can see the camera mounts right here. And then the second picture is pretty much the full assembly. You can see there's the payload on the top. This is our 3U CubeSat. And then right on top of the CubeSat is our camera. And then we have the avionics bay in the middle, held by the coupler. And then these blue blocks are, the front one is the main chute, and the bottom one is the drill.
Okay.
The motor mounts assembly down. So that's how the rocket separates. So
okay, I'm having a little trouble with getting access to one of your things that I want to look at. Are you 10K COTS?
Right.
Yes, we are.
10K COTS.
Okay.
So the top here is our motor mount system. You won't be able to see this assembly, of course, because it's already inside our lower airframe. But here's our avionics. Oh, it's not here. Did you want to go over into detail of like everything in the avionics, or is it just?
I mean, I want you to be. Listen, let's give this a good hour to hour and a half. I want you to be as detailed as you can.
All right.
Take me through. Okay, here's what I want to. Let's do this way. Let's go over the body first, just the general manufacturing. What how the nose cone is made, what the body tube is made of, how the couplers go together. How you design, how you're handling recovery, how you're what mode you're using, how you're retaining it, and then we'll talk about your payload a little bit.
All right.
So let's start with what is the rocket? What is the airframe made out of?
So the airframe is completely made out of fiberglass phenolic. Yeah. It's a 6-inch diameter body tube, and it's 112 inches tall.
Okay.
The nose cone has an aluminum tip, and we're separating both from the avionics bay. So our upper airframe body tube is permanently connected to our nose cone via screws. And
okay.
Yeah, so we eject, and then we have the lower airframe, and we just have we're ejecting from the switch band on the avionics bay.
Okay.
In terms of our lower airframe, that's just 6-inch diameter fiberglass phenolic. We use blue tube for the motor tube. We have 3 half-inch thick plywood, birch plywood or Baltic birch plywood centering rings.
Okay.
And we just have a fiberglass layup on both sides of each centering ring. We also have a thrust plate at the very bottom of the rocket. It's an aluminum thrust plate, and then we have 3 1/4-inch by 20 stainless steel rods going through all the center rings and the thrust plate, holding it together. Our fins, we have 3 fins, and they all have fin tabs. So we cut slots in the body tubes to put those in, and they each have a 4590 tip-to-tip carbon fiber layup.
Okay. All right.
Sorry.
When you talk about the fins, have you done any mathematical modeling of the fins sorry, it's late. For basically fin flutter?
Oh, yes, we have. If fin flutter should be on there.
Here's fin flutters.
It should be a calculation. Oh yeah, there you go. Yeah, so right now our calculated fin flutter velocity is 9,286.42 feet per second.
You are not flying anywhere near that fast.
Yeah,
Yeah.
no. Well, hope not. Not for this. Okay, but yeah, that's our main number.
Okay. And you're looking, okay, 17 foot. Go back. What was your thrust to weight ratio?
All right.
6.3. Okay. What is your static margin? 1.5. Okay, that's not too bad. Thrust to weight 6.3. That's reasonably good. What does the rocket weigh overall?
So right now it's 45 pounds.
That's with loaded. Or is that dry?
Loaded with motor, wet mass. So complete with the.
That's flight ready. It's 45 pounds.
Yeah.
Okay. M1340, nice motor. Launch go 17 feet. Okay. So let's talk about your nose cone itself. Are there any electronics in the nose cone?
No, there's not.
It's just basically screwed to the front half of the upper payload
Frame,
bay.
and it's holding in our payload.
And then the payload is right behind the nose cone.
Exactly.
And how are you retaining the payload?
So inside the upper airframe is a Bluetooth coupler that we epoxied on, as well as a bulkhead to attach the main chute. And that's permanent in the upper airframe. And then we would light in like various foam blocks, the camera, and then the payload. And then we would put on the nose cone and screw in the nose cone. And that would.
So let me follow that through. Basically, you stand the thing on its end, the nose cone's off. You drop the payload bay in there. Then you put the nose cone on, and that's what holds the payload in place.
Yeah. So and then we screw in the nose cone to the upper airframe, and that holds in the payload.
Okay. And then on the underside of the payload is where your attachment point for the main parachute is.
Yes.
Okay. All right. Have you on your, let's see what else I got here. Body tubes are. You said it's a fiberglass.
Glass phenolic.
Oh, it's glass phenolic. Okay, so you're using like PML phenolic with a glass laminate on it.
Yeah.
Okay. Let's see, structure notes. Okay. Okay. At some point, we're gonna lay the rocket out. And you're gonna show it to me, but we'll save that. Okay. Let's see. The couplers you said are Bluetooth.
Yep.
Those. Okay. So you built the avionics bay out of Bluetooth.
Yeah. I mean the couplers both Bluetooth. Yeah. We can. Yeah. It's right here. So
The coupler, the coupler that your electronics slide into is made out of Bluetooth.
Yep. Exactly.
Yeah, but yeah, this is the coupler. So this is the switch band right here, and this is the Bluetooth.
Okay. I'm gonna see if I can make that picture a little bit bigger. Oh wait. Yep, looks good. Okay. So how do you let's go over your coupler. That's gonna have your deployment electronics in it. You have what are you using for your deployment electronics?
Wait, let me call.
Yeah. We're gonna get our avionics sticker for a second.
Okay.
But let me scroll to the avionics portion of that's great.
It's sitting on the table.
Hello. All right, this is Hala, our avionics teacher.
Hi there. Good evening.
Good evening.
Okay, so
I see what looks like a whole bunch of electronics and wire.
Yeah, so can I just explain to you just like a general overview of everything?
Yeah, you're on. Yeah, you're on till I start throwing.
Cool. So we have two systems. We have the COTS and the SRAT. So our COTS is an Easy Mini, which is right here.
Yep.
And so this one's our primary main altimeter for our rocket. And then we have our SRAD board, which is over here. And what that of is 4 sensors. So we have a magnetometer, a gyroscope, an accelerometer, as well as a barometer. And then we have our microcontroller on there, which is the TNC 4.1. And we use all this data, but primarily the data of the accelerometer and the BMP to be able to calculate such things such as apogee, as well as when to eject our E-matches. And then our E-matches are ejected through these MOSFETs on each end. So once we reach a certain altitude or once we reach a certain condition in our code, we just send digital signals to these MOSFETs as well as to eject the E-matches from these sides. And these kind of terminal blocks, they have wires that go to the terminal blocks on the bulkhead. I can grab them if you want me to show you. And then we also have a port over here, which connects to our radio frequency module, which is over here. Give me a second. This is the RFD 900X. So we use this for our ground station system. So this connects straight to the RFD 900X on the ground station, which is connected to our laptop, which we have a whole web app for.
Okay, so you're using 900 megahertz for your
yes.
Okay.
Yes. Yeah. And then this is our bulkhead. This is with the terminal blocks. So essentially wires go into them, and then out of that goes ejection well, E-matches, which go into the ejection wells with black powder.
Okay, standard design. Okay, let me ask you this question. You have you have a GPS. The Easy Mini has. What are you using for a tracker?
As in a GPS, we have 2 GPS systems. We have our COTS GPS, we have the Featherweight, as well as we have an SRAD GPS, which is the EC5.
Okay. Have you made sure that this is probably not going to be essential, but that the RF from the 2 GPSs will not adversely affect any of your electronics?
Yes, we have, because we've tested them in the last test launch, as well as we tested them separately over here. I mean, together over here, and we made sure that they have no interference with their antennas.
Okay. The reason I ask is that on some altimeters, they get a little around RF, and they have a habit of going boom on the pad.
Yeah, for sure. Yeah, I think, for example, for this one, when we were doing testing, because these antennas, they transmit like a specific number of power per wattage. So when we were doing testing with LEDs will of course turn on because they have such low current draw. However, when we're doing it with E-matches have much higher current draw, as well as they're much farther on the bulkheads than they were on the so we don't
what are you using for power for your electronics?
So yeah, we have a battery over here. We have a lithium-ion battery.
Okay. Are you aware that soft pack lithium ion batteries are not allowed?
Yes, we are aware of that. However, we have, that's why we have another battery that we're going to use for actual competition. However, we buy these batteries that are soft pack in order to just do testing, as well as just they're kind of a cheap way, but we've addressed the rules that, as well as the ones that are in LiPos are not allowed. So we've addressed those rules, and we're making sure to buy the exact batteries that are allowed for competition. But these are just for testing.
No, I just want to make sure, because last year I saw at least 2 rockets catch fire on the pad.
Oh, that's not good.
Do you? That looks like your sled there that you have. Is that 3D printed or is that wood?
3D printed.
Okay, what is it made out of?
It's made out of
PETG.
Yeah, PETG.
Okay. Have you guys been to that? Have you guys been to the competition? You guys have not been out to this field before.
No, we have.
We have not. No.
Okay, you need to. Okay, one thing you want to understand that at the event it is going to be hot.
Mm-hmm.
Your rocket is going to lay in the sun probably for hours. So if you're using a thermoplastic inside the machine, make sure that it is good for easily to approach 150 to 175 degrees inside of your rocket. Especially if you do like last year's team seemed to have a passion for, is painting the rocket black.
Yeah, no, we won't be doing that.
Yeah, ours will be white.
Completely
okay. That, I mean, we saw one team, basically they used, I think they used PLA, and they were trying to ice their rocket down on the pad while waiting. I just want you to be aware that it is going to be hot. It's going to be, it's going to be laying on a rack in the sun for 2 to 3 hours. So make sure that just keep that in the back of your head. Okay.
Yeah, for sure.
I would encourage you, if you're at all concerned, have one of you stop at some camping supply store and buy one of those Mylar blankets. You know, the reflective ones.
Okay.
And what you could do is you can, when it's parked outside, drape the rocket in that.
Okay. Sounds good.
Something reflective, basically.
Gotcha.
Okay, so we'll go through the arming process. How are you going to bring this thing to life when it's on the pad?
Sure. So essentially, once it's on the pad, all the wires from the E-matches are all connected, and there's black powder and ejection walls and everything.
Yeah.
So once we put it on the pad, we actually have two screw switches over here. So we have this screw switch, which is for our COTS altimeter, and then we have another screw switch, which is for our SRAD board. So once we put it on the pad, we screw one individually, and then we listen to the buzzer because we have a buzzer on each altimeter.
Yeah.
And make sure each one of them turns on, and then we do the second one, and then we make sure each one turns.
Is the same switch turning on your telemetry?
Yeah. Yes. It's turning on power to everything.
Okay.
Yes. So nothing will be powered once we put it on the pad, unless we turn on the screw
So
switch.
basically, when you put it on the pad, you're going to you're going to turn it on, and then we're going to have to wait for you to obtain a GPS signal and all that
Yes.
to be talking back to your ground station.
Yes. However, we've done it in our last test launch, and we've realized that once we screwed it in, we got the GPS signal as well as the RF signal pretty fast. So it should be.
Okay. Have you tested your ground station any distance from the rocket?
Yes, we did our test. We did our test launch, and we tested it with our ground station, and we got live data the entire time.
Okay, but the thing is, your ground station is going to be at least 1,000 feet from the pad.
I see.
Okay, so that's something you're going to need to make sure
We'll make a note for our upcoming test launch to test if we get a fix like starting from a far distance.
Okay.
Yeah.
You're using 900 megahertz, so you can't RDF. When people are using 70 centimeter, I encourage them to bring a different antenna with them, but that doesn't apply to you guys. What my concern is, what's your max velocity?
It's on the open road.
It's like 297.
The reason I'm asking is, when you fly, you know that odds are on the boost, you're going to lose GPS track.
Yeah.
The problem is any of the GPS modules you can buy don't sample fast enough.
I see.
So, but that's just something you need to be prepared for, that you may lose GPS. And it'll once it's under recovery or once it starts coasting and starts slowing down, it will likely begin. It'll attempt to lock again.
Yeah.
Yes.
Usually it does.
Mhm.
Okay. Let's see here.
Yes,
What
our
else?
B, just for reference, is Mach 0.87, which is 942 feet per second.
Okay, that's not bad. Okay. Okay, so let's see. Just going over all the stuff I got here to look at. Okay, so we went over the nose cone. We've gone over the body tubes. We know what they are. Do you know that you have to mark your team name, your radio frequency on the rocket airframe someplace?
Okay.
Team name on the.
Team name and radio frequency.
Yes.
You want basically what you want to make the rocket fully identifiable on the exterior. So you're gonna want your team name someplace. You're gonna want your frequency. It would be very helpful to the reviewers at the convention center if you mark the center of pressure and the center of gravity in flight worthy condition. These are things we're going to be looking for in real time. Your motor is COTS. I assume Rick is going to be the one who's going to be handling and assembling it for you.
Yes.
Okay. Let's see here. Recovery. Let's talk about recovery. You have you're going to do a standard drogue apogee at 10,000 feet or 11,000 feet. I think you said is your predicted altitude. Where are you doing your main at?
1,000. We're doing it at 1,000.
Okay, that's a good altitude. You got an 84-foot. Have you read the calculations on descent time
Yes, it's sometimes on there.
or descent speed?
Yeah.
Okay. Let's see here. Are you shear pinning it?
Yes, shear pins.
Are you shear pinning the places where it separates?
Yes, we are.
Okay, I assume you've done the calculations on the charge to cut the shear pins, and you've tested your deployment, right?
Yeah, we did
Yeah, we've
just a
done-
couple of days ago.
Yes, sir.
Yeah, yeah,
Okay,
It
you
is.
got your main is 4.5 grams of black powder. Your backup is 6 grams. Oh, I like 6 grams of black powder. That's gonna we're bordering around on a warhead here. 6 meters per second. That's 18 feet. Half inch, 600 pound, 6,000 pound Kevlar. Let's see. What are you doing with your parachutes to avoid tangling? Are you using swivels or are you just
We have a tying procedure, like a folding procedure.
Yeah, we just have like a folding procedure right now.
okay? What I was asking is, do you have swivels on the parachutes where they attach to the harness
No, we don't.
when the rocket spins? Well, I saw that you have U-bolts, so I'm not worried about. So when people use eye bolts instead of U-bolts, I like to see a swivel there, because what you don't want is the bolt to unscrew. That can't happen to you.
Yeah.
But you have a folding procedure that I assume Rick probably taught you.
Yeah,
Yeah,
Rick
he
taught
did.
us.
You're using a Fruity Shoots Iris. I saw that. That's a good parachute. Are you using a deployment bag or are you just using a blanket?
Yeah, we're using a blanket and then dog barf.
Ooh, wow. Dog barf, breakfast of champions. Okay. Let's see here. Couplers are good. Material count payload. Okay, let's go ahead and take a few moments. Let's divert. Let's bring the payload team on. I'm good with electronics.
All right, sounds good.
Okay, yeah, all right. Should we bring the CubeSat?
Like, would you like to see the physical payload too?
I would like to see it. Yes.
Okay,
Bring the payload
yeah,
too.
bring the, yeah.
Guys, bring the payload.
Release the payload. Oh, you guys got a good view out of your lab.
Yeah, I mean our lab's like a hallway.
Oh,
Yeah, I got a couple of garage doors. But yeah, so Lilas, okay, you want to introduce yourself?
Okay. So,
Hello, I'm Lilas. I'm the
you're the payload. You're the payload person.
Yes.
Hi, I'm David.
Okay.
I also work on the payload team.
Doctor, give me a dog and pony show about your payload.
In detail.
Yeah, so this is what it is. It's in a 3U CubeSat shape. The shell is stainless steel. Sorry. This inside is the electronic sub-assembly. This is where we house all of our electronics, and it's where mostly just collecting data on the TNC 4.1.
Okay.
I can go over the electronics a bit more if you'd like. It's basically just a redundant data collection system. So we have 4 sensors. We have 2 IMUs. We have 1 pressure sensor, and we have a humidity sensor.
And you have a camera too, don't you?
The camera is
And
mounted in the payload bay, but it's not a part of like the CubeSat.
It's just recording.
Yeah.
Okay.
If you're curious for that, we're using a GoPro Hero 4, and that's just logging to an internal SD card.
That's just for you guys, right?
Yeah.
Okay. So okay, I see the electronics. How does it go into the CubeSat?
so the CubeSat,
it just slides around.
it's open, so we just slide this in, and then we have a top and bottom cap.
Okay, then if I understand correctly, there's in the upper payload bay, there's a bulkhead that's permanently attached. This is going to sit down on top of that, and then the nose cone goes on to screw down to retain it inside the body tube.
Correct. Yes. Exactly.
Okay. How do you turn the payload on?
So we turn it on. We just connect it through the battery, and then that's where we put it into the payload bay.
Oh, so it's live when you install it.
Yeah.
Yeah. So we turn it on before we put it in, and then we secure the nose cone on, and then that's it.
Okay. Do you have to understand something? there, from the time you turn that thing on, you may be 2 to 3 hours before the flight. Right? Do you have, make sure you calculate you have a battery for it.
Yeah. So we've done all that, and we've done like overnight tests. We've done like 8 hours.
Okay.
10, so well,
I want you guys to do well, so I'm going to throw things at you that I hope
no, I appreciate that.
will push you in the right direction. Let's see, payload. You're using it's aluminum 3D. It's not 3D printed. It is not. The payload will not be deployed. Correct?
No.
Okay. Electronics, nothing there. Team number. Okay. Make sure that someplace on the payload you have your team number on the payload somewhere.
I see. Okay.
Wait, and also just to correct you, so the structure is stainless steel, quarter-inch stainless steel, and then the shells of our payload are also 3D printed out of PTG.
Okay.
Yeah.
All right. To me, I'm just asking about what's saying here. I'm more interested in flight safety. As long as the payload is fully constrained, you've calculated your static margin based on the mass of the payload. I'm good with it.
Right.
I'm an engineer. I'm nosy. Okay, let's talk about. Okay, so we can move on. Thank you, ma'am. Let's talk about the tail end of the rocket now.
Yeah.
Okay. Once again, it's the same. It's the glassed phenolic, correct?
Yeah.
You told me you're a fiberglass fin with, I believe, with a carbon fiber layup on them.
Yeah. So they're quarter-inch Baltic birch fins.
Okay.
And then 45-90, so 2 layers of carbon fiber to the tips on each side.
Okay. Did you vacuum bag the fiberglass, the carbon fiber?
Yes.
Okay. Let's see here. Let's see here. What do I got here? The fin attachment. The fin attachment. They're through the wall fins, so they're mounted to the motor tube, and then they're filleted on the inside and the outside.
Yeah.
Okay. Let's see here. Do you do a tip-to-tip layup on top of the fins?
Yeah.
So the fins themselves are wood with carbon fiber. They'll be installed on the rocket, and then you lay a sheet of fiber.
Sorry. To correct that, so it's wood. We put it on the rocket, then we do the carbon fiber to the tips.
Okay.
Yeah.
Okay, so you installed the fins in the rocket. They were bare wood when you did.
Yes.
And then you laid 2 layers of carbon fiber at rotating angles up for maximum strength. Okay. Let's see. The motor tube is once again is blue tube. The motor mount is blue tube again.
Yes.
All right. Center wings were quarter-inch plywood. You said.
Half-inch.
Half-inch. Okay. And they're basically just epoxied to the motor tube, then epoxied to the inside of the motor, the airframe.
Yes. Injection bonded.
Am I correct there?
Yeah.
Okay. What are you doing for launch rail guidance? The the rail guides.
Yeah, so we just have one rail button on the lower airframe and one on the upper. We want to see the exact position.
Okay. You say you have about how far apart are those rail buttons?
Exact. I believe they're about like 40 inches.
Okay, so I want you guys to think about something. You have 2 points that you're attaching it to the rail. If for some reason you are slightly cattywampus coming up, at some point you're only going to have, the rocket is going to be traveling up the rail, and you're only going to have one guiding point on the rail. You now have a pivot point.
Right.
I would strongly encourage, if you can have this arrangement, a third button somewhere between the tail of the rocket and call it the center of pressure. Pick one of the center rings and put another one in there. You want that thing, you want two mounting points on the rail into the last possible second.
We haven't installed the lower rail.
So we haven't yet. Yeah, we should have 2 on the lower airframe. So we have 3 total.
So sorry, just to for better understanding, you said in between one of the centering rings, so like under that current rail button right there.
Hang on, let me call that up. So so you have a rail button someplace close to the base of the rocket, correct?
Yeah.
Then another one in one of those centering rings for the motor tube, right?
Mhm.
Is that what you're saying?
Oh no, like right now we have one in the upper airframe, one in the lower airframe, and are you saying to put it like even low, like one more even lower, or one near
I
the
would
center?
put, okay, if you look at where your fins come up in this profile drawing, see that forwardmost centering ring around the motor?
This one?
Yeah,
Okay.
I would put a rail button somewhere in that area.
Oh, so like right next to this one.
Okay, no, okay, so then you want one. Okay, this is just a suggestion. You can take it on. You want one close to the bottom of the rocket.
Uh-huh.
Yeah, like what?
Yeah. So like one here, one at the bottom of the rocket.
Yeah,
Near the
you can leave the upper one on there. That's
Yeah.
not a problem.
Yeah.
I'm saying my concern. I had thought your aft one was the one on the lower section. I thought it was at the base. That's when I was worried about a pivot point. This is not as bad. You're probably okay. If you want to do belt and suspenders, I would consider a third one, but it's not a down check in any way, shape, or fashion.
It's good security. Just good insurance.
Yeah, so I mean, yeah, we installed the rail button, the upper one already. We haven't installed the lower one. So when we are to install them, you would recommend one on the like the bottom centering ring, one on the top centering ring,
Or somewhere down there. I would consider it, but I'm not going to say it's mandatory.
Okay.
The reason I'm saying this is that if your rocket is not fully up to speed when that first button clears the rail.
Uh-huh.
Now, if you think about it, you've basically got a pin there that the rocket can swivel on, but still be going up the rail.
Yeah.
It is going to be windy there.
Uh-huh.
So if you're not moving fast enough to overcome the effects of wind, it could hypothetically push the rocket.
Right. Yeah. While it's
rail.
Is it better to like have three or just have two on the bottom?
It's better to have three. Does that make sense to have three? If you have it on the bottom,
you
like
need one on the
last second, to make it as straight as possible.
You know, half an inch above the thrust plate,
Okay.
Yeah.
something like that. Like I said, it is not a down check. It is something I would urge you to consider.
Okay.
All right, let's see what we got here. How are you holding the motor in?
We have a motor retainer.
Okay.
It looks like that.
Yeah. You can. The black is the motor retainer. It can be.
It's
screwed-
basically an aero pack.
Oh, I'm sorry.
It's an aero pack retainer.
I'm not sure what brand it was.
Yeah, I'm not
It's
certain.
a flange mount with a big screw, with a ring that screws onto it.
Yeah,
Yeah.
exactly.
Right. Yeah.
And it's a 75 millimeter motor, right?
You can check. Is it 90?
Would be it.
Oh, we have the motor section.
Oh, yeah.
I'm saying the motor's you're not using any adapters. It's a 3-inch motor mount. And you have a 3-inch motor, right?
I believe so, yeah. So let me just verify that, just make sure. Oh wait, no, yeah. It's right here. So
Motor section. Oh.
98 millimeters.
But it's a 4-inch. Okay.
All right.
That's that M1340 that you're using.
That's what we're using. Yeah.
Okay. Oh, it's a single use motor. Okay.
Yeah.
All right. All right. Okay. So that's fine. Let's see here. Retention, useful info. Okay. All right. Well, why don't you guys take a moment? I'm gonna make this picture bigger. Go get the rocket.
Okay.
Okay.
They're in here, right? How should we show? You want to just flip it?
Yeah.
I don't know if I can flip this camera. Oh wait, I can. Okay. All right. So where do you want to start?
Let's walk back the length of the rocket.
Okay, we can actually just slide it.
Okay.
Together? Okay.
Yeah, we
Oh yeah.
slide.
Yeah. Can you give us a second?
So it looks like a Pop-Tart wrapper.
Don't worry about it. That is not our rocket.
We got 2 teams.
All right. All right. So, oh, okay.
All righty.
It.
Let me look at the tail end. That looks good. There's your retainer. The motor will go in there.
Yep.
That's just, you're fully retained. Okay, let's move along the airframe. Do you have the coupler? The coupler is in there.
Yeah, it's right there.
Okay, where do your shear pins go?
Right along these edges right
You
here.
see, yeah, the holes.
And those holes up there? Well,
Yeah.
Okay, because that's right. This is going to be a 3-part separation.
Or 2-part.
Well, the fin can's going to come away, and the
Yeah, this is gonna be 3 parts. That's what he said.
yeah.
Oh,
there's
yes,
gonna be
yes, yes, yes.
Lower, the coupler here, and then the upper.
Yeah.
Yeah.
It's typically called a zipperless recovery system. Okay, I
Okay.
see you have vent holes there. Those 6 holes are your vent.
Yeah,
6
these
vent
are
holes.
vent
Yeah. Yep. Vent holes there, and then on the lower 2.
Yeah, there's vent holes here.
Okay. Okay, I'm talking about the vent holes for the electronics. That's those little holes.
This is where the screws, we access our screw switches, but they
Okay.
also act as vent holes.
Okay, you're gonna probably want to add a little more ventilation than that.
In the
Okay.
avionics?
Yeah.
Yeah.
Avionics bay.
Okay. Yeah, we have one here, and then we have another
Okay.
one.
Okay. One would just not be.
Yeah, one was for
quite-
the one was for the S ride.
Oh, actually, I think we might have a third one. Yeah, we have 3, actually. We have 3.
Okay,
we have one-
that's perfect.
Yeah.
Okay. Now those next row of holes there, those are the holes that for the screws that hold the
Shear pins, yeah, shear pins,
Shear-
and then vent holes.
Okay. You're gonna
Yeah,
use how
for
many
the
shear pins
holes
are you
payload.
how many shear pins are you using?
So we're using 5 on each airframe.
Okay. And you're comfortable with able to break those?
Yes, we just did our
Okay.
test yesterday.
Okay.
Yeah.
Moving forward, you see your camera.
Yeah, camera.
And
And
then-
here, these are the vent holes for the payload.
And then here's the vent holes for the payload.
Okay.
And then this is where we screw in the nose cone to the payload.
To the upper airframe.
So if you want to pull out the nose cone so you can see, sorry. So he's gonna pull out the nose cone.
Okay.
Careful. Sorry. Okay, so the nose cone is off. And then
Okay. And then
inside is where we put in the payload.
okay, that's where your payload's gonna go. Gotta slip into that blue tube right there, right?
And then we're gonna put we have 3 foam blocks to put around it just for extra cushion.
Okay.
And then
then-
the amount causes makes it so that it can't rotate.
Okay, then so the payload slides down that tube. The nose cone. Is there another bulkhead that goes there, or is just that bulkhead?
No. So we have a bulkhead on the nose cone.
And that just presses down against the
Yeah,
payload.
again. Yeah, exactly.
So the payload cannot shift in flight. It's the big thing.
Or it cannot. It cannot.
Okay. And then on the underside of that bulkhead there, I'm looking down the tube, is your attachment point for your main.
Yeah, so if you wanted to pull this out.
I would
You
like
can
to
put that
see
down.
that.
Wait, put it on the ground. On the ground. No, like
With the
standing.
wood.
Okay, so now they're gonna. So the parachutes are actually in it right now since we just did a test.
Okay.
But
Yeah, here's the shot.
yeah, like the shock cord's in there, and then the parachute's in there as well.
Okay, so the parachute, one end of the shock cord is hooked to the back, that back plate where the it's up there somewhere, right?
Yeah, it's where the U-boat is. So the U-boat's like right here.
Okay. Then the other end, of course, will connect to the forward end of the cord.
Yeah, past the bulkhead. Careful, make sure this doesn't fall. Yeah, and then it'll be like this, kind of like this.
Yeah.
And
Okay.
This is where the shot.
Okay. All right, then, okay, so you can just slide that back together. I assume you're using 2 completely redundant sets of charges?
yes, we have both
So-
primary and secondary. Yeah.
Okay. Are you doing redundant on both main and apogee?
Yes.
Okay. When for your back, okay, what do you call it? The easy mini is your primary, right?
Just like
Yes.
Okay, the secondary
Mhm.
at apogee, is there a delay after the primary?
Sorry, can you repeat that?
Is there a delay after the primary?
Basically, do they go off at the exact same time, or typically?
Oh no, they do not. They do not. No.
So
Yep.
the main will go off, and then usually for the apogee, like when I fly mine, I set them to 100 feet below the main altitude. I mean the apogee deployment.
Yeah.
So-
So hold on.
and
What is the of the secondary?
Oh, so I think
Two and a half.
yeah,
We
we put
said
them
2.5
2.5 seconds.
Okay, so using time. Okay, same for both the main and the drogue.
Yeah.
Okay.
Yes.
All right. Typically, when you do the drogue, this is just once again my experience. The drogue, you set it to like for me, I'll set my drogue for apogee, and then I'll set my backup drogue to 100 feet below apogee. But time works too.
Okay.
I see. Okay, I see.
Time is up.
100 feet.
The reason I do that is if you do time, you don't know how much acceleration you've built up going down.
True.
Yeah.
You're right.
And I
Yeah,
like
we
to have and at 10,000 feet, 100 feet is nothing.
Mhm.
But if you tip that rocket over, and let's say it's pointed straight down, how far is it going to fall, and how fast is it going to be going in 2 seconds? And how much effort will that add to the system trying to deploy the nose cone?
Yeah.
Just a little thing to think about.
Yeah. We can base it off the
Sure, we'll
out.
think about
Yeah, we'll think about it for sure. It's
Just
just that.
think about just what I want you to think about is I just want to make sure that if the primary does not work as planned,
Mhm.
make sure you are not nose down accelerating when you try to set off your secondary. There's a couple of things can happen. One, aerodynamic forces could hypothetically keep the nose cone from coming off. Two, that nose cone comes off. It does come off. That rocket flips over, and the shock cord. Are you familiar with what a bandsaw is? It'll
Yes.
zipper the hell out of the body too. And that's so you want to make sure that the secondary charge goes off when the rocket is still reasonably slow.
Okay. Okay, we can look into it for sure. Thank you.
All right, let's see. Good Lord, my computer's doing things that are not natural. Gotta find, where did that go? Oh, gosh.
We can try.
Oh, Ben, where's your email? Bear with me for a sec. I gotta find. I lost something. Secretary. Report 3. 2 attachments. Okay, give me just a sec here. Where'd you go? Oh, there we go. Let's see here. That looks good. Okay. I'm just going through anything else I need to ask at this point. You're picking your I assume, is Rick getting your motor for you, and is he going to bring it, or are you picking it up?
Yeah, Rick's gonna bring it.
We're
Okay.
actually.
Yeah. Let's see here. FOR, TRA numbers. TAM license is not required. I couldn't care. It says here, where's the team staying? I couldn't care less. I really couldn't, let's see, motor ordered. Do you guys actually have the motor? Does Rick have it already?
He'll have it in 2 days.
Okay.
Yeah, 2 days.
No motor, no fly.
Right. We'll throw it extra.
Throw it real hard. Okay, so I mean, it would be. I mean, this is the thing is, what part of what I'm also trying to do is make sure that you don't waste your time. I don't want you guys. I'm happy with the rocket. It looks good enough for me. And besides, when you get to the convention center during the final safety review, whoever does it is going to make you take that rocket apart down to its component atoms, and you're going to rebuild it for them right there in front of you.
Okay.
Well, I mean, and I'm being hyperbolic. they're gonna make you take it, disassemble it, and show them every hard mounting point. You know, they're gonna basically gonna do a complete safety review of the rocket again.
Okay.
And and then after that, it gets safety reviewed again after that. We're trying, you know, a couple of things is one, we're playing with big rockets, and two, we don't want to do anything that makes the landowner mad because it's the only place we have to do this. Okay.
Right.
So motors ordered. You're not doing SRAD, that does not apply. Okay, one thing I'd like to see, just show me your parachute attach. You said the parachute was attached. What are you using to attach it to the shackle points?
Or to the shock cord. We just tied a fishing knot.
Yeah, we just tied it.
I assume one of you guys is an Eagle Scout?
One of them.
Yeah.
Actually,
The guy tying the knot.
Yeah.
Okay.
Eagle Scout.
I mean, I
not
don't know if he's
specifically
an Eagle Scout specifically, but he is a scout.
Eric, what kind of scout were you?
I'm just joking. I'm just joking. You know, I mean, I tie my shock cords all the time. I think on the average that they would have probably preferred that you used a sewn loop and a what do you call it, and some kind of quick link.
Mm-hmm.
I'm going to note this in my thing that you're planning on tying it. People are going to want to inspect that knot, so you need to make sure that whoever ties that knot really knows how to tie a knot.
This is
So we just blame him, right?
So for the bulkheads, we've been using an improved clinch knot for most of the bulkheads. And then
Okay.
For the other one,
Fishing knot.
I think we did the same thing for the W bolt. I think that's the only one we used.
All I'm saying is when you
For the parachute,
Oh yeah, for the parachutes, what type they use?
we just use a straight knot, like through that one.
say that again.
We just tied a simple knot for the parachutes attached. To
Okay. Okay, I am going to have to note this in my report because it's doable. It's not ideal. Okay.
Do you have any suggestions for knots that we?
What I would do is it's a little late for this in the game now. I would have found a shock, like there are a couple companies that manufacture shock cords with loops sewn in the ends of them. Okay.
Did we?
I don't think these are.
So you would recommend getting like quick links?
Well, I would use there's a company called what's it? One Bad Hawk, and he makes Kevlar shock cords with loops sewn into them. You can tie the knots, but what I would do if I were you, I would tie the knots at home. Make sure you're really happy with them, and then for the with the loop that the knot forms, use a quick link to attach that to the airframe.
So the quick link will attach to our U-bolts?
Well, if I understand what you're saying, right, is you basically take the shock cord, take a loop through the U-bolt, and then just tie a knot, correct?
Yes.
What I would do is I would tie that knot to a quick link, and then use the quick link to attach to the.
So like a caliper or something. I don't. That's what.
To the U-bolt, right?
To the U-bolt.
Also, like we have two separate sections of the shock cord.
So you basically treat the quick link like it's your U-bolt, okay? Yeah. Tie the knot to that.
Okay.
And then when you're ready to attach the shock cord to the bulkhead, use the quick link to do that. Does that make sense?
Yeah, that makes sense. Mm-hmm. That would have solved a lot of like the things we had.
One of the reasons I'm doing this is I want you to make sure your knot is really good. Because if I inspect your rocket and you're doing this, I'm going to want to see that knot. Right. Okay. And if I'm not happy with it, that could be a down. The other thing is, depending on where you're going to be working on the rocket, do you want to be sitting out in 110-degree weather tying knots?
No.
So that this is something to make your life a little bit easier. Let's see here, motor, body tubes, everything's good there. All the markings. There is I'm sure you have this document called the Spaceport America Cup Rocket Review Checklist.
Yeah, I think so.
You might have one.
Like, did we go over it already? So,
Well, I mean, just make sure you go through that one more time.
okay.
And let's see here. I think I've got everything. I think you guys are in pretty good shape. The only two things that I'm going to suggest, like I said, is think about that third rail button, and then I would really think long and hard about the logistics of connecting your shock cords up. Okay.
Yeah.
One last question for you. Rocket is assembled. It's on the pad. Can you reach the electronics from the ground, or are you going to need to be working on a ladder?
We can reach it from the ground.
Okay.
Like, yeah.
Some experience.
We never used ladders.
No, like, yeah. I mean, it's a switch, man.
Okay.
It's like 5 feet off the ground.
Okay. So even if the fin can is a couple 2-3 feet up, you
Yeah.
can still
Yeah.
reach up there and reach it. Whoever is going to be arming the rocket on the pad, you have armed this rocket on the pad before, correct?
Yeah. Yeah.
Right.
So you know that the Easy Mini, at least in my experience, the stuff by the company that makes Easy Mini, their beepers tend to be a little on the soft side.
Mhm.
They're not real loud.
I mean, no, we have our own, but we attach our own buzzers as well, which are pretty loud.
Okay, I just want to make sure, because I always suggest to people, if all you're depending on is the Easy Mini's actual little buzzer built
No,
onto
yeah,
it. Okay.
we never depend on that. We have 2 separate buzzers, one for the astronaut and one for the COTS.
Okay. The reason I said it is it's gonna be windy and noisy. You want something loud that you can hear.
Yeah.
And if you can't hear it, when you get 3 or 4 friends around you, turn the radios up all the way. If you can't hear it, bring a stethoscope.
Okay.
I carry mine out to the pad when it's so noisy. I have a stethoscope I put on the side of the rocket so I can hear the beeps. All right, guys, I think I'm in pretty good shape. I'll fill the form out. I will send you guys, as I've been doing in the past, my summary with a thing. I think you guys are ready to go. I wish you all the best of luck. I'm looking forward to seeing you in Las Cruces.
Thank you so much.
Can't wait to see you there. Yep.
You guys have a good evening. I'm gonna go fall on my face.
Yeah.
Thank you,
Have
you too.
a good night.
Okay, take care, guys.
Thank you too.
Bye-bye.
Bye bye.
Bye.
Right. Possibly have more. I can't find it.